Hey guys, in this video we're going to talk about residential demand estimating. Demand estimating refers to the methods used for determining residential electric loads. This is a necessary task for sizing transformers, and it's necessary for sizing the service conductors connected to the customer's meter. Everything we're going to cover applies to a single new home built by a homeowner, and it also applies to many hundreds of homes built by a developer, maybe for a subdivision in your own community. In my experience, electric utilities differ a bit on exactly how this is done. So I'm going to demonstrate how my local utility does it. Based on state policy changes regarding electric vehicle charging, our local utility has updated their standards and have made some pretty significant changes. So this is good timing if you're currently involved in new business construction or applicant design work of some sort. We'll provide a link in the description to the utility source documents that I'll be referencing here. And I should warn you, this is going to involve a lot of charts. In order to estimate the electric demand for a new residential home, we first need to understand this chart. This chart shows the anticipated electric loads for a variety of residential dwellings. This includes single-family detached homes, single-family attached homes, which includes condos and townhomes, multifamily homes, which are typically apartments and apartment buildings, and it also includes mobile homes. The chart shows different size ranges for each type of dwelling. The smallest range shown is 0 to 1,299 square feet, and the largest, the 3,000 to 3,399 square foot category. Homes or dwellings that are larger than this are considered to be in the custom home category. We'll show how to deal with custom homes in just a moment. The anticipated electric loads for each dwelling are shown at the top, beginning with the base load plus electric heating column. If a home will be constructed to include electric heating and air conditioning, the second column would be used. If the home will include electric water heating instead of gas water heating, column 3 would be utilized. And finally, if the home will be all electric, the loads in column 4 would be used. As of January 2026 in California, in addition to the base load selected, electric loads need to be added for all new homes that will be required to include electric vehicle charging. Depending on the actual type of EV charging installed, this can fall in the range shown of 1.2 to 19.2 kilowatts. If the actual EV charging load is known, that value should be utilized. If the EV charging load is not yet known, the National Electric Code recommends the value of 7.2 kilowatts to be used. Let's look at a simple example. Assume a single-family detached home is being constructed on an empty lot by the homeowner. The size of the home is going to be about 2,500 square feet. They're building the home to include electric heating and air conditioning. The water heating they've decided to handle with a gas water heater. The base load for this home would then be shown in the base load with air conditioning column. And given the square footage, we end up with a base load of 12.2 kilowatts. Let's also assume the family doesn't currently own an electric vehicle. Without knowing exactly what type of charger would be required, should they purchase one in the future, we'll use the recommended estimate of 7.2 kilowatts. So the total anticipated electric load is simply 12.2 kilowatts plus 7.2 kilowatts for a total of 19.4. That brings us to another chart. The electric utility transformer that will be installed outside the home can come in a variety of sizes, from 25 kVA up to 167 kVA. Each of these transformers are capable of serving electric loads within a certain range. For this new home and the load of 19.4 kilowatts, a 25 kVA transformer would be all that's required. Before we do another example, we need to understand something called a diversity factor and another chart. In the previous example, our homeowner was building a single home, which we estimated to have a total electric demand of 19.4 kilowatts, 12.2 kilowatts for the base load, and 7.2 kilowatts for the EV charging. Because of this, we also determined the appropriate size of transformer to be a 25 kVA transformer. Diversity factors become important when multiple homes are going to be served from a single transformer. For example, if a developer was building a residential subdivision consisting of 4 homes, all identical to the one in the previous example, we would end up with 4 homes, each with an estimated electric load of 19.4 kilowatts. Multiplying 19.4 by 4 results in a total load of 77.6 kilowatts. However, electric utilities recognize that the likelihood of any single home using its maximum estimated electric load is pretty small. When multiple homes are served from a single transformer, the likelihood that all of the houses ever operate at their maximum estimated demand at the same time is something that almost never happens. Because of this fact, diversity factors have been created that reduce the total anticipated load to something a little more realistic. If you look at the diversity factor chart, when 3 to 4 homes are all served from a single transformer, the diversity factor of 0.75 can be applied to the base load of 12.2 kilowatts. You'll also notice that EV charging is not diversified. Hence, the diversity factor of 1 is shown for EV charging loads. When these diversity factors are applied to our estimated loads, we end up with a total diversified load at the transformer of 65.4 kilowatts, about 12 kilowatts less than the undiversified load. Notice one more thing. The estimated demand at each of the homes does not change. The diversified value of 65.4 is the total anticipated demand at the transformer. This is the value that will determine the transformer size required for the 4 homes. And in this case, we'll need to use a 75 kVA transformer. Now let's assume a developer is building a small subdivision with 12 new homes. Each home will be about 1,800 square feet in size and will be all electric with no gas appliances. According to our residential dwelling demand estimating chart, each of the 1,800 square foot all electric homes lands our electric demand right about here, 14.8 kilowatts. And since we don't have any information regarding the EV charging load, we'll use the default of 7.2 kilowatts. So our demand for each home is 14.8 kilowatts base load, plus an additional 7.2 kilowatts for the EV charging. If we decide to install 1 transformer for every 2 homes, we would group them something like this. Our number of houses per transformer would then be 2. The diversity factor applied when 2 homes are being served by a single transformer is 1.0 for the base load and 1.0 for the EV charging. So we have diversity factors of 1.0 for the base and 1.0 for the EV load. Doing the math results in a total demand at the transformer of 44 kilowatts. And according to our transformer sizing chart, a 44 kilowatt demand can be served with a 50 kVA transformer. In fact, we'll need 6 50 kVA transformers to provide service to the 12 new homes. I'll let you do the math, but if 4 homes were served per transformer, it's also possible to use 3 75 kVA transformers. 2 100 kVA transformers would also work. Or a combination of transformer sizes are all acceptable methods of providing service to the 12 new homes. All right then, so far, all of the demand estimating we've done has come from this chart. This is typically the source reference document for estimating residential demand for most new developments, whether someone is building a single home or a 200-home subdivision. I mentioned a few moments ago that the largest square foot shown on this chart was 3,000 to 3,399 square feet. Homes larger than that are considered to be custom homes. Let's take a look at the demand estimates for custom homes. And look at that, we have another chart. I love charts. Decisions become very easy to make when you have a chart telling you what to do. This is the custom residential dwelling demand chart. This chart has a list of the most typical electric appliances you would find in any home: lighting, water heaters, dishwashers, and so on, all the way to the bottom of the list, where we have a residential EV charging station. It also shows the estimated demand of each of these appliances in kilowatts. And over here in the second column, we have something called a demand factor. A demand factor is exactly the same as a diversity factor. A diversity factor diversified the load based on the number of customers connected to a transformer. A demand factor does exactly the same thing, but it reduces the estimated demand of each appliance by assuming not all of these things will be running at the same time or operating at their maximum rated power. Except for this one. The EV charging is the one that doesn't seem to get diversified. Let's take a look at an example. Let's build a 5,000 square foot new home. We'll install a lot of lights with a demand of 4 kilowatts. The chart shows lighting has a demand factor of 0.5, so our total lighting load is 2 kilowatts. Our house will have 2 water heaters rated at 4.5 kilowatts each. Both have a demand factor of 0.5 for a total load of 4.5 kilowatts. We have a space heater at 7.2 kilowatts and a demand factor of 0.5 as well, for a total load of 3.6 kilowatts. 2 clothes dryers, a dishwasher, and a cooktop at 12 kilowatts with a demand factor of 0.8 for a cooktop load of 9.6 kilowatts. Our client wants to install a swimming pool with a lot of outlets and 2 EV chargers for their 2 cars. We end up with a total estimated load of 49.5 kilowatts. It should also be noted that this by no means is an exhaustive list of every possible home electric appliance. If your client likes to weld on the weekends or has a machine shop installed in the basement, be sure your local utility representative is aware and understands the additional electric demands of that equipment. So our 5,000 square foot custom home has an estimated load of 49.5 kilowatts. And since we're installing the transformer to serve only this customer, the diversity factors are 1.0 for both the base load and the EV charging. So our total load doesn't change. And for that, we need a 50 kVA transformer. Pretty cool, huh? Thanks for watching. We'll put the links in the description.